I believe it is that in the backside, just that paper there, yeah. Okay, just as a review from yesterday, the polyatomic cation ammonium loses that electron to form the positive charge. So today we're looking at the polyatomic anion carbonate. Now, you can notice up here, right, that we have 6 electrons around the oxygen and we have 4 around the carbon. Now what's going to happen is one of these electrons from the carbon is going to, this radical, this lone pair, is going to move down and bond with the oxygen here, because that gives us a full octet. Does everybody see that? Yep. Full octet. Now over here you can see we're missing 2 electrons. Yeah. So it's going to seek out and gain 2 electrons. It's going to gain one there, and it's going to gain one right here. These are the 2 places that it's missing one. We should probably put that in a different color so it's a little more obvious. Maybe we'll try that in a green.
Put an X, so that's pretty obvious.
Okay. But some people like color, so we'll do it in color. Color, we'll put it in green. So these 2 green electrons have to be captured from somewhere. Where are they going to get them? That's a good question. Wherever they're available. A lot of reactions require input energy to occur. They call that activation energy. So the input energy would be where it would get these electrons. In the sense of like a change in temperature, more movement. Some reactions are exothermic. What does that mean?
They release heat?
Yeah, they release energy. So there's energy out there moving around that it can capture. Exothermic reactions generally release that. So overall, you're going to have a 2 negative because it wants to gain those 2 electrons. It's a polyatomic anion. Once again, if you come across a polyatomic ion you don't know the name of, there's a thing called the internet. This is a website called Bing, and you can type in the polyatomic anion, right? And it comes up as acetate with a negative charge. Now, I highly encourage you to do this. I'm not so bent out of shape of you memorizing the polyatomic names. Naming isn't, super important for me because I would rather you measure twice and cut once. If you're so confident in your naming, you might end up making mistakes because you think you know all the names and you're looking at a bottle and you thought it was this but it wasn't that, and then you cause a reaction that you weren't predicting. So it's very good to be a little bit cautious with naming. Do not be overly confident in naming because it can cause a lot of problems if you get the wrong name or the wrong bottle and you're reacting with something. It could cause all of your research to disappear. If you're doing a research project you've been working on for like 6 months and you just add the wrong chemical, bam, the whole thing is gone. So people get a little bit concerned about that. If you go into a lab and you're overly confident, people will kind of question that a little bit. Most jobs, from what I've been reading about out in California, they really want you to have experienced some failure a little bit so that you are, I guess you would say, a little cautious. What I'm getting ready to show you is kind of a long version of this abbreviated version I gave you when you came in. This flow chart, Heather. Flow chart right here. So when you come across a compound, the first question you should ask, is there a metal present?
If so,
there. A metal or NH4+, because NH4+ is considered to be what? It's a cation. It's a polyatomic cation, and I guess the hydrogen in it is making it a similar to metal in characteristic, but they're grouping that together. I don't know for sure. Why? Because nitrogen is a non-metal and hydrogen is a non-metal. There's always an exception. That would be the exception. So if there's a metal present, it's going to be ionic, right? And if it's not, it's going to be covalent. So if we look here, it's most likely because the ammonium ion is transferring an electron. That's what metals do. They transfer. So if it's behaving like a metal, they're going to say, well, psh, must be a metal. Up here is another flow chart. So what type of compound is it? If it's ionic, what should it have in it? Yeah, it should have a metal or that ammonium ion. Covalent, composed generally of nonmetals. See that right here? Nonmetals. Acid. Acids typically produce the hydrogen. You can use pH tests to confirm that. All acids start with what? All acids start with what? H. So if you see H on any label, you can pretty much assume it's going to be an acid. Now water can be an acid, depends on what's in it. So we've got two types of acids. We have the anion does not contain oxygen, and we have the anion does contain oxygen. So would a hydrochloric acid, HCl, fall into which group? Which group would the HCl fall into?
HCl.
Yes. Would it fall into the oxyacids or the acids? Yeah, it falls into the acids. HCl, there's no oxygen there. Good job, Cody. Excellent. Raise your hand next time. If you raise your hand, Cody, I can give you points. All right, so up here we have the covalent compounds, type 3, non-ionic. And we have the ionic compounds. There's type 1 and type 2. So type 1, one type of cation is observed. Type 2, more than one type of cation is observed. So what does that mean? More than one type of cation is observed. Well, yeah, you can see what you see on the handout. NH4 plus would be an example of more than one type of cation is observed. NH4 plus. So for the ionic, like we just mentioned, you have your regular metal, and then you have polyatomic, like the NH4 plus. This group here, the nonmetals, they change their ending to what, Cody? What group did the nonmetals change their ending to? Raise your hand. Adam? No, it's I. So up here you can see that the periodic table is your friend, and that oftentimes they will color code it for you. So this one is very well color coded. The Army did a really nice job. You can see all of the elements in green are going to change their ending to I. So like it's not going to be oxygen when it bonds with sodium. It's going to be sodium oxide.
Money to pay back student loans.
Sodium chloride. So sodium bromide. Sodium phosphide. Sodium carbide. So keep that in mind that ide is probably one of the easiest things to name that is on the periodic table when we're looking at these monatomic ions. Heather, you're working somewhere and you've worked there 21 days in a row. You're at the point where you've memorized that. Now some people, if you go to like brain games, some people are really good with analogies. That's good for short-term memory, but unless you're using that analogy like every single day, the analogy you create like 2 weeks ago, you've already forgotten it. It's not going to stay deep within your brain unless you're using it quite frequently. So the more you use it, the more likely you're going to be able to memorize that. The problem is that in the workplace, we constantly make new things. Like Ford is coming out with new cars, like they got the Raptor. They didn't have the Raptor like 3 years ago. So you got to be aware that you have to pay attention to what you're doing, and do not be hesitant or afraid to look at data tables to ensure you're.
It says normal 60 to 100.
So you're sure you.
Mine's 42.
It was at 58 at first.
He's just made up that.
No, I looked at it. It's the reason.
No.
Oh,
He said earlier 96.
96 was very high. Just chilling. Yeah.
Okay, so be aware that when you go into your workplace, if you're making something new, that's when you want to go a little slower. Oftentimes, people want to do everything fast, and those are the people that make a lot of mistakes. Because when you start making a product, if you've been making it all year, you get really good at it. I don't know if you know that, but if you practice something and you're practicing correctly, you'll get really good. The problem is that after the next year when a new product comes out, be a little careful. Brain Games acronym, where you have Nick the Camel ate a clam supper and crepes in Phoenix. Okay, so there's a analysis for this. Nick is associated with the nitrate. This is what I did in college. I did a lot of this, especially in Spanish. Camel's the carbonate, clam. Now 3 weeks from now, I didn't remember any of it, but if you're trying to get through a test and they're making you memorize, these things work really well. And then supper's the sulfate, crepes is the chromate, Phoenix is the phosphate. So this is the method they're using to help you remember. Now the polyatomic ions are named based on the oxygen. You might want to write that down. That's important to know. When we name these polyatomic ions, they're based on the number of oxygens present.
It's like you said, polyatomic ions are based on oxygen.
Yes, I'll show you a table for that in just a second. Atomic anions and the cations, why? Close. The anions tend to be nonmetals, and they tend to be in a gaseous state, so they can move around in water a little easier. They get in the atmosphere a little easier, so they move around. And they also have the desire. They have the ability to attract an electron. There are a lot of chemical reactions that are happening that are exothermic. What does that mean, exothermic? Right now?
They get hot on the outside?
Right. Like if you burn wood, Chris, you ever been to a campfire? You ever been to a campfire? You ever seen a fire?
Yeah. I made one.
That's an exothermic reaction. Naming compounds flowchart. And there'll be a few things on the notes here that are not on the flowchart. For example, like where it says acids up here, on your paper, they're not getting technical as far as whether the acid contains oxygen or not. But you might want to write on here just as a note next to the acids, it says acid. You might want to write over here next to it that there are two types of acids, those that contain oxygen and those that don't. An example of one that doesn't contain oxygen would be like hydrochloric acid. Can anybody give me an example of an acid that contains oxygen? Yeah. You have acids do not contain oxygen, would be like HCl, like you have chlorine in your pool. If you ever go swimming and they put chlorine in it, okay, hydrochloric. If you are familiar with like acid rain, everybody ever heard of acid rain?
Yeah.
Well, like when you burn carbon-based fossil fuels like methane or coal, that carbon reacts with oxygen to form carbon dioxide. That reacts with water to form carbonic acid. And that would be an example of an oxygen acid, carbonic acid. Sulfuric acid has oxygen in it. Step 1, determine whether it's a metal. Step 2, determine the type and whether there is one type of cation. Here we got an example of the alkali metals, 1 positive and 2 positive. So this would be one type of cation, like the main group. The transition metals, they have more than one type of cation. It could be positive 2 or positive 3. And we have to use what to name those? If I remember. The Roman numerals. So if you look on your homework from last night, you'll see here that iron 2, that's the English version. Now if you want to go back to Latin, most people don't study Latin anymore. That would be the ferric, would be iron 3, and the ferrous would be iron 2. Gillian, when you get to the workplace in the future, you always want to double check when you start something new. Now, memorizing things comes if you've done it like 21 times in a row. This is why basketball coaches, football coaches, and baseball coaches always make you do repetitive action, because that's what helps you have what's called muscle memory, right? So if you're doing something a lot, you're going to get it memorized. If you're just doing it short term, like you're just studying for a test, you're memorizing it, that's not going to be good enough to have confidence you're not going to make a mistake when you go into the lab. I will always check the chemical twice before I use it, because I haven't done it enough. Now, if I'm going into the workplace, I'm doing the same thing over and over 21 days in a row, you can be a little more confident. But guess what happens, Chris? You make a new car, like a new Raptor, you make a new product. So whenever you start a new product, go back to the idea of, yes, we should be a little careful, because if you make mistakes in the beginning, that's gonna affect your bottom line or your profit at the end of the year. You're not gonna have as much profit because at the beginning of the year you made too many mistakes. You were trying to go too fast. Oftentimes people that get confident in memory go too fast and they make mistakes. Like if you were doing a chemical reaction or a lab and it was, let's say, 3 months in the working and you went too fast and made a mistake, all that data now is just like gone because you made that mistake there. Y'all heard about the Hubble telescope and its problem? You know, they put up the whole Hubble telescope and what was wrong with it?
They did the whole last one, right?
Yeah, it was out of focus.
Yeah.
Yeah.
Put up huge
It happens a lot more frequently. Typically these polyatomic, or correction, these transition metals, or they have multiple charges, right here. We typically use the Roman numeral to tell us what the charge is on the metal. Now, if you go back to the Latin origin, you can use ferrous and ferric, which is associated with the charge. The ferrous would be the 2 negative, and the ferric would be the 3, correction, the 2 positive, can't really say it very well, and the 3 positive. Roman numeral after the cation to indicate the ion charge of that cation. So we've done the first 3 on our naming covalent compounds, and then we did the next 3 when we're taking the actual formula to the name. And we're using our chart up here to give us the prefixes. So we have the tetra, phosphorus, pentasulfide, dioxide, and selenium hexafluoride associated with this chart right here. Nice job, Alu. Fantastic. Oxygen. You basically are going to call it the hydro and then the root element name like chlorine, and then you're going to change it to ic. So it's not chlorine anymore, it's not chloride, it's going to be chloric acid, like hydrochloric acid. Make sense? Same thing is true with fluorine, so it'd be hydrofluoric acid, hydrofluoric acid, hydrosulfic acid, same thing. Look at, when you're naming these oxyacids, you have the root polyatomic anion you have to look at. So if this is boric acid or carbonic acid, you have to look on the sheet that I gave you, and it says if it had an ic ending, you're going to go to the 8th root word. So the carbonate, go to our homework sheet from last night, you'll see the carbonate right there on the sheet where it says carbonate. If I can zoom in there for you. CO3, 2 negative. So that's going to be the root acid here we're talking about, CO3, 2 negative. The formula for carbonic acid is H2CO3 because the CO3 is the carbonate ion, polyatomic anion, and you're going to need 2 hydrogens to balance that. 2 hydrogens to balance it, right? And the paper once again shows you the 8 to ic that you have to look at on the name. So if you're just given the name, this is how you figure out the formula. TT. It's like one of those school policy. Thank you, TT.
Where was I?
You're doing really well. Good job.
Wait, hold on.
H.
Okay, we know what area is. And H, little 4?
4. What about right here? Oh.
Just showing that she did it. Yeah. What's the first question you should ask? Diana? When I see this chart, what's the first question I'm asking?
Is it ionic or covalent?
Okay. But if you look underneath there, what does it say under ionic and covalent?
Is there a metal or an NH?
Right, so is there a metal? Now, if there's a metal, what is it?
Ionic.
Very good. So if it's a metal, it's ionic. Memorize an activity is to do what? Yeah, to keep doing it over and over again. So if you did it 21 days in a row, it would pretty much be a pattern. Muscle memory would take into effect. The problem is if you just are starting to do it, people tend to rush, and that's when a lot of mistakes are made. Most companies will start a new product at the beginning or the end of a year, like an automobile or a cell phone. When these new products come out, you want to go a little bit slower so you can get used to doing it, right? 3 up there on the board for naming these covalent compounds. So I'm going to check the rest tomorrow for homework. So you're writing those down. If you have questions, ask me. Iodine would be I. 4. Most students will struggle with naming these even if you give them the data tables. So it doesn't really bother me. Most people will not get a full credit on this, even with the data tables. This is an example of a common polyatomic data table. If you notice right here, there's a pattern, and that's the oxygen. This has got 2 oxygen. This has 3 oxygen. Guess what? They both have the same charge. Why? Because that's the pattern that we've noticed. This one has 2, this one has 3, so this is nitrite, this is nitrate. Right, the ite means less oxygen. 8 means more. Most people know 8, I ate food. Maybe you ate more than you should have. Maybe it was Thanksgiving. Maybe it was the buffet at where? What's your favorite buffet? Raise your hand. Jumbo buffet? I know, Chinese buffets, they're hard to get away from. Right, the acid, you have to have hydrogen in the front. So we have acetic acid, the ic goes to 8, so we got acetate up there. And you see the acetate is C2H3O2.
So where are all the other ones, like hydrobromic acid? It's hydrobromide?
Which one are you asking about?
The 4th one, hydrobromic acid.
Alright, so you have ic, that's going to be 8, that's going to be bromate. You don't see bromate up there, so we have to find another chart. Now with KS, remember you're still doing CO3, so you've kind of got off track. I think you looked at the wrong one. You stepped over one, but that's all right. Just correct those, because people will ask. They'll be like, That's okay. Just correct them, because people will ask for you. As you can see that people are writing things down.
I am.
Hey.
Look at me.
Jacob hasn't written anything down.
Look at me.
Oh,
Make sure you
excellent,
put that on.
excellent. No, you write it up there, I'll tell you what's
Can I
right.
do number 11, Mr. Hunter?
I want to do it.
I do number 11. I got number 11 right.
Is your final answer?
Yes.
You're wrong.
Can I do it just in one bite? What? But I'm Eastern usually. First we gotta go.
Good job. Memorized. 7. Emma. All of them. 6. 6. None of them. None. Actually, it'll help you memorize 6 of them. Very good, Noah. You can see 2, 3, 4, 5, 6. Yeah, I'll give you 3 for that. That's good. I heard you. I've got it on video. So you know that there are, how many polyatomic ions did you memorize? Did you see a lot of them? Yeah, there are quite a few. Now, the Army periodic table, they give you on the back, you'll notice here, they give you, it looks like around, I don't know, 15 to 20 there. And there are charts that have anywhere from 30 to 40 polyatomic ions on them. This one, now when I was at U of L, I used these a lot to help memorize things like Spanish. So they're very helpful to memorize. Keep that in mind. John, I'm writing down and we're going over the homework tonight. I guess you can go home and do it tonight later on, 2 o'clock in the morning. Oh, sure. Now you're switching to the sulfur now. You're still on the CO3. You looked over a column.
I know, like,
You're good.